Good day. Allow me to present a work on the topic simulation modeling of the whole electromagnetic transducer for measuring the tightness of ferromagnetic field. Okay, the structure of that presentation consists of the following points: introduction, block diagram, grid structure, Hall sensor model, mathematical justification, magnetic field distribution, computational results, and conclusions. The classification of information models in computer simulations. It's three models type. Mathematical models, symbolic models that describe specific numerical sequentials and relationships. Graphical models, it's a visual representation of objects and processes, particularly useful when other description methods are inadequate. Simulation models, it's enable observation of behavioral changes in system elements, called computational experiments and parameter modification. Next slide, it's a block diagram showing computer modeling stages. A complete sequence from initial problem analysis toward final model application is demonstrated on the picture, and which illustrates the methodological framework, problem statement, information model, constructions, software tool selection, algorithm development, and result validation. Next slide, it's a grid structure in AMR simulation of a shock wave interacting with an inclined surface. Okay, high performance competition plays a theoretical role in modern simulation. Moreover, modern simulation software such as ANSYS provide extensive tooling for modeling fluid dynamics. One of the most effective technique-wise is adaptive mesh refinement, which allows the computational grid of automatically adjust its resolution in regions where the solution exhibits rapid changes or high gradients. This significantly increases accuracy without proportional increasing the computational cost. In AMR simulations, the computational grid dynamically refined in response to local features of the solution. The computational domain is divided into nested grid with each successive level provided finer spatial detail. Okay, Hall sensor model is a computer model in which a coil is shown in red, a measuring glass containing a sprayed metal layer in green, a Hall plate in a yellow Hall plate with statistical values. And Hall effect sensors work on the principle that a transceiver voltage is induced in a current carrying conductor when it is placed in a magnetic field. The picture shows a computer model of the sensors and its visual element of the Hall plate. Consider a conductor in the form of a rectangular plate toward which an electric current flows. In the absence of magnetic field, the potential difference between point C and D, which one of the equational surface equals zero when the sample is placed in a magnetic field with magnetic induction B, perpendicular to both the current direction and the sample plane, a potential difference VR develops between point C and D, termed the Hall electromotion forces. Next slide, it's a mathematical justification, and the following set formulas explains the relationships in Hall effect dependencies. And this is formulas. It is forces, Lorentz forces, Hall coefficient, charge, current, and another parameter. So, magnetic field distribution patterns, it's a magnetic induction on horizontal section for Hall plate center magnetic induction on vertical section for coil center. The computational results validate the theoretical understanding of electromagnetic field behavior in solenoid configurations. The highest absolute values of magnetic flux density occur within the coil volume, particularly near the coil edges with the maximum magnetic field. Range is concentrated near the winding periphery. These field distribution patterns correlate with the established theoretical predictions as illustrated in this picture. Hall voltage distribution depended on air gap and Hall plate thickness. As the air gap between the inductor and the coated substrate increases, the magnetic field range within the Hall plate decreases proportional, while the Hall coefficient remains a thermodynamic constant. And next slide, it's calculated Hall coefficients and resultant voltage variation across the Hall plate dimensions provide quantitative metric for evolution measurement sensitivity. The analysis indicates that the effective measurement range of the purpose sensor system extends from 0.001 millimeters to 0.2 millimeters for deposited metallic films, which encompasses the requirements for various industrial applications. Beyond 0.2 millimeter thickness, the measurement sensitivity decreases significantly due to magnetic flux saturation effect within the paramagnetic coating. The details results are permissions in this table. And conclusions. A detailed three-dimensional computational model of a Hall effect-based electromagnetic transducer has been successfully developed and analyzed for the purpose of measuring paramagnetic field thickness. The simulation model incorporated geometrical, electrical, and material parameters of the system, including the coil, Hall plate, and test substrate, and was implemented using the finite element method in ANSYS Maxwell. The simulation results provided comprehensive insight into the spatial distribution of magnetic flux density and field strength under various conditions, including change in sensor geometry, air gap, distance, and counting cycles. Thank you for your attention.